going to reInvent or any of our AWS conferences, we also generally have certification lounges rather, that you can go and hang out in and meet other certified individuals, talk with other certified individuals, network, and it's generally a really great environment. So it's fun to go meet other certified individuals and chat with them and, well, trade stories. Now, as far as our AWS certifications, this workshop will be covering, we'll be starting and covering the AWS Certified Solutions Architect Professional Exam. This falls in line with the architecting pillar. Generally speaking, you would take the professional exam after the associate exam. That being said, we have removed the prereqs for all of our exams. So you no longer need to sit and pass the Solution Architect Associate exam before you can pass the professional exam. With that being said, I generally do recommend that you do take the associate exam just to understand what the AWS certification process is like, what our test questions are like. As I've already said, our test questions are very different from a typical IT-based exam. Now, the other benefit here is when we pass the AWS Solution Architect Professional exam, it will all automatically re-up you or renew your Solution Architect Associate exam. So these two exams go hand in hand, and continuously recertifying on the SA Professional will of course also recertify you on the Solution Architect Associate. Now we also have our developing track with our Developer Associate leading to our DevOps Engineer Professional exam. Same with our Operations SysOps Administrator Associate, which leads to the DevOps Engineer Professional. And of course, we do have quite a few specialty exams as well. So our advanced networking, big data, or data analytics now, certified security, as well as machine learning specialty exam. So I believe we do have workshops for the other specialty certifications, developer, DevOps, SysOps administrator as well. So something to look forward to if you are planning on taking all certifications, or rather, sitting for and passing all certification exams, which of course we all want to do because that's fun. Now, as far as the SA Professional exam, we do break all of our exams up into, well, a few different domains. Now, the SA Professional exam is broken up into 5 different domains. Domain 1, designing for organizational complexity, which is worth approximately 12.5% of the exam. Domain 2, designing new solutions. Well, it's worth approximately 31% of our exam. Migration planning. %60 of the exam. So I need to really study that and then just study migration planning. That gets me 75%. I can then ignore cost control and designing for organizational complexity. That's not really the case. We want to ensure that you have a broad understanding of all of these domains. This is just trying to explain how we are breaking out the exam itself. Now, as far as the exam questions go, you'll be set at regardless of if you take this in a testing center or if you take the exam at your house, you'll be sat down and you'll have a little window that pops up where we have the exam question. And as I said, all of our exam questions are multiple choice or multiple answer. We have a nice little sliding bar at the bottom, shows us where in the exam we are. You can click on any of these questions and go directly to that question if we need to revisit. So here we have our question, are monsters bad at math? Select one. Now this is just a multiple choice question. Yes, no, only if you count Dracula. It's a nice pun. And the final one, the internet was made for cat videos. Well, clearly we know the answer is the internet was made for cat videos. So we're going to select that and hit answer. Once we hit answer, it should take us into the next question. If we're not sure, if we think maybe the internet was made for dog videos, not cat videos, we can still select the internet was made for cat videos and then flag this question. This will place a little flag on our sliding bar at the bottom, so we can always revisit that question after the fact. Once we've answered every question, we have our wonderful little end test button that we'll click, and it will confirm, are you sure you wish to end the test? You hit yes, and it will take you to a summary screen where you'll see all of the questions that you've answered, all of the questions that you've flagged, or the number rather of the questions that you've answered, unanswered questions, and flagged. Now, here is one of the probably most important things that I will say in this workshop. All of our questions, multiple choice or multiple answer. There is no partial credit for our questions. There's also no penalty for guessing. So if we're running out of time, it is very important that we just run through and answer every question. When we end this test, there should be 0 unanswered questions. With that being said, most of the time, when we answer all the questions, we can go to this review, the summary screen, and this gives us the ability to go back and review all of the questions that we've flagged that we were just unsure of. The reason this is important is a lot of the times, if I get a question on a service, say we have a question on setting up and properly managing security groups. Well, I answered the question, but maybe I wasn't fully sure of the answer. A lot of the times, a subsequent question will answer or solidify the answer for this question I wasn't sure of. Now, you're also given a piece of paper and a pen. Now, that has to stay behind when you leave the test, but that gives you the ability to take notes that you can review for your previous questions as well. It also, on some of the longer questions, is very useful for you to just kind of write down and highlight the main topics that the question is dealing with. Now, as far as the exam, and well, anything else with your name on it. I've used a library card, I've used a debit card before. The last time I took an exam, I actually used a race license that just had my name, it had nothing else, and it was a card that was printed out for me. But you do need to have a picture ID with you, so driver's license, passport, some government issued ID. Now, when you come in, or before they take you into the exam room, they will ask you to empty your pockets, including car keys. So when you drive to the test center, it's usually a good idea to leave your cell phone, your wallet, locked up in your car. Now, there is a locker in the test center, so you can place your car keys in this locker, and they'll make sure that all you have on you is your ID when you go into the test center. Now, you'll be escorted into the test center, logged into a machine, and they will start the test. They'll have you review and make sure that they've opened up the right test before they sit you down, close the door, and well, now you're taking the exam. There is an NDA that must be signed before taking the exam as well. Fairly standard, just saying you're not going to post the answers to the exam questions on the internet or give them out and distribute them anyway. Now, as far as the exam itself, as I said, all of our questions are multiple choice or multiple answer. If it's a multiple choice question, you'll know that just says select the best answer. If it's a multiple answer question, it will tell you how many answers you have to select. In fact, you can't hit next until you've selected the correct amount of potential answers. So if it's a select 2, it'll say in brackets select 2. You have to highlight 2 answers before you can move on to the next question. Now, as far as our multiple answer questions go, there is no partial credit. So if it says select 3 and you get 2 of 3 right, that's not 2/3 of a point. You've gotten the question wrong, unfortunately. Now, as I said, there is no penalty for guessing. Therefore, you should never submit a test with unanswered questions. Now, you do have 170 minutes to complete the exam, which is actually quite a bit of time. So it's very important that you do not rush yourself. You have plenty of time to flag questions, take notes on the questions, go back and review the questions, and just make sure that you are confident in your answer. Now, with that being said, another very important strategy that I tell every one of my students when it comes to taking our exams is, well, don't second guess yourself. If you thought initially that an answer was correct, that was your first instinct, your gut reaction. And generally, your gut reaction is right. And I can personally attest to the fact that nothing is worse than failing a certification exam by one question, a question that you had initially marked right and then marked or gone back and changed to an incorrect answer after the fact. Now, after you've answered all of your questions, you do have the ability to go back and review all of your answers just to double check them. Once again, keeping in mind, initial reactions a lot of the time are in fact correct. But it does give you the ability to review everything just to ensure that you're confident and all of your answers were correctly marked. Another thing, make sure you click on the right answer. Make sure you read all of the answers. And I cannot stress that one enough. If we have a question that has 6 answers and you read the question and immediately go, I know what the answer to this is, and you read the first answer and it has the subject or the service that is the correct answer, make sure you fully read that answer and all of the other ones to ensure that it is actually correct. Now, when it comes to just basic general strategies, as I said, fully read and answer, or fully read the question and read all answers at least one time. Now, if you do see 2 answers that, well, both appear to be right, reread the question. Generally, there's a qualifier at the end of the question, something similar to in the most cost-effective manner, or with fault tolerance in mind, or with regards to security. And that will generally indicate which of these 2 potentially correct answers are actually correct. So understand all features, all configuration values across all answers. Identify what configuration requirements each answer actually has, as well as, well, one of the nicest things about a lot of our exam questions, there's generally one very, very obviously wrong answer. Now you can eliminate this obviously not wrong answer, and if there's only 5 answers, well, now you only have to pick from 2, or from 4 rather. Now generally, of the remaining 4, 2 will be very similar, 2 will also, or 2 of the questions will be very similar. So highlighting which of these 2 answers is correct or the most correct is going to be very important. Now, let's see. All right, so now that we've gone through just a quick introduction, and I realize at this point, now that I've been talking for 20 minutes, that I was, well, really horrible in my presentation here. I forgot to introduce myself, so please give me a second to do that now. My name is Scott Gilbert. I am a technical trainer with Amazon. I've been with Amazon for over 5 years in the role as a technical trainer, which means I get to go around and talk to all of our customers, our users, train our or go through and teach our instructor-led classes, so architecting, advanced architecting, security engineering. I've quite literally traveled all over the world talking about AWS and meeting all of our awesome and amazing customers. We also have Mark, Peter, and Sam, who will be answering your questions as you place the questions into the GoToWebinar chat panel. And I'm assuming at this point, they've already been answering chat or questions. I apologize for not introducing you all at the very beginning of this. And I apologize for not introducing myself. So with that being said, let's go ahead and dive into the first domain. This will then give us the ability to grant access to our resources with as much granularity as we can possibly control. Groups or roles perform any action, both policies are evaluated at once, in parallel, at the same time to determine, do they have access to this policy or not? Now, of course, we know that group or user management is far easier to add multiple users into a group, one policy to manage multiple users. And of course, our roles are temporary access. A user can assume a role, or a role can be assigned to an application, to a serverless function, to an EC2 instance, granting that application access to resources as well. Now, as far as managing temporary access and delegating our temporary access, because we do have multiple, or most organizations will have multiple accounts, we could, of course, create an IAM user for Carol and Bob across each account, but that's going to be kind of difficult. Managing all of our IAM users across every account will be very difficult at scale in a best case scenario. So what we can do is, of course, delegate our access controls using STS or security token service. We can grant temporary security token, building a trust relationship between account 1 and Bob. Bob will authenticate across account 2. He can request temporary security credentials and gain, well, his access to account 1 without needing to log in and re-authenticate with a user account Bob in account 1. So delegation gives us a very simple, easy mechanism to grant cross-account access while still maintaining our security controls and following the policy of least privilege. Now we also have user federation. We have a few different mechanisms for federated access. With federation, we are effectively offloading authentication from IAM and utilizing an external IDP or identity provider. So I can have my user authenticate against an external identity store. On successful authentication, depending upon how we are setting up and configuring our federation, we are building a trust relationship between our corporate identity provider or off AWS identity provider and AWS. So if we're using SAML, our user will authenticate against their local identity provider. Once on successful authentication, SAML assertion is passed back to the browser, and our user will be redirected into the console. SAML or OIDC, very, very easy identity federation configurations to set up within AWS. We also have directory service or AWS directory service, which gives you a very simple, potentially way to extend your existing Active Directory into AWS. And we do have 3 different flavors of directory service. AWS Managed Microsoft AD, AD Connector, and Simple AD. Now, Simple AD is just, well, as the name would imply, a very simple Active Directory running within directory service, which is a fully managed Active Directory service. Now, it's low scale, low cost, but very basic Active Directory. Very useful if we have less than 5,000 users that are authenticating. It's not, however, a full AD. If we do need a fully managed, fully licensed AD, we have AWS Managed Microsoft AD, which is an enterprise licensed Microsoft AD useful for 5,000 plus users and gives you a managed Active Directory inside AWS. Now, as I said, if we've already configured Active Directory in our on-premises data center, we can always extend that functionality into AWS using AD Connector without then needing to, well, reconfigure, rebuild, or reinvent the wheel, as it were, and deploy Active Directory into AWS as well. So a couple just basics of this subdomain. Let's go ahead and get into the first question. So question 1. Your company's new dev team requires access to SAML-enabled applications on AWS. The system admin would like to rely solely on the company's on-premises Active Directory to use existing user credentials. A user portal for logins and MFA is required for easy access and added security. How would we design a solution for federating users into AWS? That's a good question. You might see similar questions to this on the exam, but let's go ahead and break down this question. What are we actually asking here? We have a few things highlighted. So first off, we have SAML-enabled apps. We have our on-premises AD. We do have a user portal for our logins, and MFA is a basic requirement. So we've kind of broken up exactly what the question requires. Now that we've understand this, we can kind of, well, what do we think a basic architecture would look like that would solve this? Well, we know we need SAML support. We know that we're using our on-premises AD with an existing user portal for our logins, and MFA is a requirement. So, well, we've got our corporate data center, our AD server. We need to connect our corporate data center to AWS Cloud to allow local authentication for SAML-enabled apps running inside AWS. All right, let's go ahead and look at some possible answers. Answer 1, configure AWS Microsoft AD to provide user authentication and set up user access via AWS sign-in endpoint for SAML and Microsoft ADFS. Connect to your corporate AD server by using Simple AD for user authentication and set up user access via SSO. Use your corporate AD server by configuring AD connector for user authentication and set up user access via SSO. And finally, create an IAM users and groups that are mapped to the corporate AD user roles and use MFA for authentication. All right, so now that we've read all of the potential answers, let's go ahead and re-evaluate these answers. So answer 1, all right, let's go ahead and ask ourselves, can Microsoft Managed AD provide a sign-in endpoint using SAML? And does this solution provide for the requirement using our client's existing on-premises Active Directory? Well, we know that Managed Microsoft AD is a full enterprise licensed Microsoft AD or managed Microsoft AD inside AWS. So it is missing a couple of the basic requirements that we had. So it fails to meet our on-premises AD requirement, which, well, we know we had. So question B, let's go ahead and evaluate this question. Does AWS Single Sign-On provide a user portal for easy login where users would not have to create new credentials? Does Simple AD support SAML or MFA? Well, we could use Single Sign-On, but Simple AD, as I said, is not very feature-rich, so it does not support MFA and does not meet the basic requirements. Answer C, use a corporate AD server by configuring AD connector for user authentication, setting up user access via single sign-on. Well, can AD connector forward our sign-in request to our on-prem AD for authentication? Yes. Does single sign-in provide a user portal for easy login where users will not have to create new credentials? Once again, also yes. So answer C meets all of our requirements. If we go back and look at answer C, remember I said a lot of the times we'll have answers that are obviously wrong. Creating an IAM user and groups that are mapped to the corporate AD user roles and use MFA for authentication. Well, I suppose that could sort of work. It's a lot of work and that's not really scalable. And that would require a lot more configuration and work than is listed in this potential answer. So we know the proposed solution, C, using your corporate AD server by connecting configuring AD connector for user authentication, setting up our user access via SSO is the correct answer. Proposed architecture, well, got AD connector with SSO for our SAML-enabled apps. All right. The next subdomain, we will be focusing on networking. So when it comes to networking in AWS, at first glance, networking in AWS is very, very simple. We configure our VPC, our site range, create our subnets, and that's pretty much it. But when it comes to actually using AWS, we need to understand how we can connect our AWS network into our other networks, how we can secure this transport. So managed VPNs, VPN Cloud Hub, software VPNs, direct connects are all going to be viable options for securing our traffic from our on-premises data center, from our corporate headquarters into AWS. When it comes to setting up and configuring our fully managed VPNs versus a software VPN, why would we want to use one VPN over another? Do we have existing hardware or VPN licenses that we want to extend into AWS? Do we want full control of the traffic? Do we need additional inspections on the traffic? This would potentially indicate that maybe a software VPN would be a better option. As far as our direct connects, we know that our direct connection is a private link, 1, 10, or 100 gig direct connect from your on-premises data center, from your corporate headquarters into AWS. Now, you will configure your customer router to connect into an AWS managed direct connect endpoint inside the direct connect location. You'll then have private connectivity from your corporate data center into AWS. You can also extend through the direct connect access to other AWS services like S3 or Dynamodb. Now, when it comes to hybrid connectivity and migration or management of our data across your on-premises data center into AWS, we have Storage Gateway, a few different options in Storage Gateway, File Gateway, Tape Gateway, Stored Volume Gateway, as well as our Cached Volume Gateway. So understanding Tape Gateway, File Gateway, excuse me, as well as our volume gateway within the Storage Gateway service, you can expect, well, a couple important questions regarding management and automation of our data across your on-premises network into AWS. As far as our VPC endpoints, well, remembering, of course, that most of AWS does not reside inside our VPC. So if I have an application residing on an EC2 instance that needs to interact with an S3 bucket, by default, that requires an internet gateway, and the request is going to traverse public internet. Now, it's Amazon's network, but that is public internet. If I do not want to have my request go over public internet, I can always use a VPC endpoint. Now, we have two different types of endpoints, gateway endpoints and interface endpoints. Right now, we have two gateway endpoints, one for Dynamodb and one for S3, which provide a private link from resources inside your VPC to either S3 or Dynamodb. And our interface endpoints, once again, provide access to your VPC resources through a private link managed endpoint, so you can connect into our resources without traversing public internet. Now, as far as question 2 or 3, or I'm sorry, 2 rather. One of our hybrid clients is having latency issues with their new video and voice applications hosted on EC2 instances. An internet-based VPN connection is being used for encryption. They're based in San Francisco and currently operate in US West 1. They want to spin up more instances into AP Southeast 1 and are concerned that latency will increase their real-time data applications. What do you recommend to improve latency and also provide in-transit data protections? We've got a couple basic requirements here. So once again, let's go ahead and break this question down. Well, one, we know that we have a hybrid-based environment. Of course, we've got data centers as well as AWS resources. Currently, we're operating in US West 1, but we want to move to AP Southeast 1. We have EC2 instances using an internet-based VPN connection, and we do have real-time applications. So we need to improve our latency, improve our performance, while still providing protection for our data in transit. So a few requirements. This is maybe a little more real-world scenario here. So for possible architecture to solve this, well, we know we have two regions, US West 1, AP Southeast 1, with VPCs in each region. We need to, from our corporate data center, set up private connections, so VPN connections that maintain as low of latency as possible to two regions that do have some, well, a decent amount of space between them. So we have a couple options here. Let's look at and read through all of our potential answers. Use AWS VPN Cloud Hub to access instances in both regions via a public virtual interface. Use IPsec for encryption. B, use VPN Cloud Hub to access instances in both regions via private virtual interface. Use AWS KMS for encryption. Use a direct connect to access instances in both regions via a public virtual interface. Use an AWS managed VPN for encryption. And finally, use AWS Direct Connect to access instances in both regions via private virtual interface using AWS managed VPNs for encryptions. So right off the bat, we see a couple things. We see 4 possible answers, and well, two answers look identical, and the last 2 answers look fairly identical. So the last 2 answers have one difference: public versus private virtual interfaces. The first answer, well, using Cloud Hub to access instances in both regions via public or private virtual interface, but also IPsec for encryption or KMS for encryption. So a few just minor differences, and this is why it's really important to fully read all possible answers. So let's go ahead and look at answer 1. So using Cloud Hub to access our instances in both regions via public virtual interface with IPsec for encryption. So will using IPsec via VPN tunnel protect our data in transit, and does Cloud Hub support on-premises as the main hub? Well, this will not necessarily solve our low latency and multi-region requirements, and well, Cloud Hub is our on-premises, or with our on-premises data center as our main hub, not really gonna work. So that kind of also rules out answer B. Although answer B, it was difficult to not laugh while I read this. Using KMS for encryption. KMS is very great for encryption of our data at rest, not our data in transit. So this doesn't, once again, solve our low latency problem, and it also is not how we're going to encrypt our data in transit. So B is not correct, which leaves us with C or D. So C, using Direct Connect with a public virtual interface. Let's see here. Can we use Direct Connect to access resources in different regions with a single link? Should a public virtual interface be used, or a private virtual interface? And can AWS Managed VPN be combined with Direct Connect to provide encrypted connections? Well, yes, it does meet all of our requirements. Our public VIFs for our Direct Connect give access to all of our resources. Unlike D, where the private VIFs wouldn't necessarily give us the connections to all of the resources we need. So 2 VPNs over a public VIF, one to US West 1, one to AP Southeast 1 is of course going to be the correct answer, leaving us with C once again. Oops. All right, so basic architecture or proposed solution here. We've got our Direct Connect with 2 public VIFs going to each region with an encrypted connection over the Direct Connect. All right. Now our final subdomain is multi-account AWS environments. So in this module, or in this subdomain, we're going to focus on managing, maintaining standards and security across multiple accounts and enforcing that. Now, of course, when it comes to creating multiple accounts, one of the primary reasons for that is isolation. We have a few different just basic architectural guidelines here. We can create one account with multiple VPCs if isolation is our only requirement. If we need stronger isolation as well as billing isolation, we can create an account and VPC for each relevant account. So we've got our dev account, prod, regulated, and our regulated global and regulated regional accounts, which not only give us billing isolation, but also further isolation of all of our resources. Now, as far as billing strategies across multiple accounts, this can become slightly difficult. We want to ensure that all of our billing notifications are sent to group aliases, so we're not reliant on one person receiving our bill. And creating and enforcing tagging strategies across all of our accounts gives us a very simple way to manage, query our resources, but also understand what resource is what, who's responsible for it, what department, who owns it when we're examining the bill. And of course, automation. We want to automate our baseline configurations with APIs, with scripts, with templates. We want to ensure that we have standardization across all of our accounts, regardless of if it's a prod account or not. Now, one really useful tool for managing and maintaining standards across multiple accounts is, of course, organizations, which gives us policy-based management for many, many accounts. We can create consolidated billing through our organizations, divide our sub-accounts up into organizational units, assign our service control policies up to the accounts, to the organizational units, so we can very easily enforce and maintain standards across all of our accounts, potentially thousands of accounts, as well as giving us the ability, a very simple mechanism to automate new account creation through APIs while also following and maintaining the standards that we've set forth. So, question 3. A company has multiple AWS accounts to separate their dev and prod resources. They want to automate their end-to-end account creation process. The security officer pointed out that AWS CloudTrail logging must be enabled on all accounts and regions. Users, including those with administrator privileges, should not be able to perform any actions on CloudTrail trails. How would we automate account creation and centrally enforce the security requirements on all accounts? Seems like a very logical but kind of important question. What are we actually looking at? Well, we have multiple accounts and we want to automate our account creation. We also have the base requirement of CloudTrail logging being enabled. We also need to protect our CloudTrail logs. Even admins should not be able to perform actions, modifies, deletes on our CloudTrail logs. How can I configure this centrally and enforce these policies, these best practices across every single account, including accounts that have not been built yet? So, possible architectures. Well, we've got all of our AWS accounts. We need to set up and manage our accounts centrally. I want to automate account creation, as well as configure and enable CloudTrail on all accounts while removing access to CloudTrail APIs and protecting our CloudTrail logs. All right, let's go ahead and look through some proposed answers here. Excuse me. So answer 1, or A, use organizations to manage and create accounts in AWS CloudFormation for configuration. Use an SCP to filter out APIs for CloudTrail. All right. Use organizations to manage and create accounts in CloudFormation for configuration. Use a permanent role denying CloudTrail to all users. All right. Use Microsoft or AWS Manage Microsoft AD to manage and create accounts and AWS CloudFormation for configuration. Move all users under an IAM group denying CloudTrail APIs. And finally, use organizations to manage, create, and configure new accounts. Manually modify each IAM user policy to deny CloudTrail APIs. Now I'm reading through all of these answers, and I read the first one and it sounded really great, but I continued reading the rest of the potential answers. Some of these, I'm hoping, were obviously wrong. A couple of them. And I'm just going to go ahead and make a call out really quick finally to, well, what is this word? This awful word right there. Manually. Oops. Manually modify every policy. That should just be terrifying, especially when one of the base requirements was automating the creation of our accounts. If we set the answer to manually modify each IAM user policy, what happens if you go on holiday? Well, account creation has to stop as well. So manual actions, probably not the right answer here. Let's go ahead and read through the rest anyway. So answer A, can organizations manage and automatically create accounts via its APIs? Can CloudFormation be used to configure the account with the needed resources as well as our CloudTrail trails? And can our service control policies be used to filter out APIs for an account? Well, yes. Answer A, right off the bat, was that looked correct. Everything in this answer seemed like a best practice. Centralized management, centralized account creation, automated resource creation, and service control policies to enforce our security requirements. I think this is right. Let's go ahead and look at the rest of them, even though I think most of them looked kind of obviously wrong. The second question, organizations to manage and create accounts, CloudFormation for configuration, that looked good, but assign a permanent role denying CloudTrail to all users. Well, first off, are roles intended to be used for permanent credentials? Absolutely not. Remember, roles are temporary. Will assigning a role remove all previous access? Well, explicit denies in the role policy might remove other access. That's not really how this is intended to be built. This is not really an effective way to deny access to CloudTrail. And if I don't assume that role, I still may have access to CloudTrail. The next one, well, this is another, I'm hoping, kind of obviously wrong answer. Can Microsoft AD be used to manage and create user accounts? No. Is moving all users, including admins, to a single group with the same permissions desirable? Most of the time, also, no. So this potential answer fails to meet our management and automation requirements, and I've already ruled out answer D. So manual modification of our IAM user policies is never a best practice. We want to avoid manual modification if at all possible. So this doesn't meet our automation requirements. So we know answer A was probably the best solution. Using organizations to manage and create our user accounts, CloudFormation for resource configuration, service control policies to filter out APIs for CloudTrail. And one of the nice things about our service control policies, even in our managed accounts, the SCPs can be used to restrict root access for these managed accounts. So it is a very effective mechanism, even for our admins, to restrict unwanted modification to our CloudTrail APIs. So we've got our root organizational unit, our prod OU, and our dev OU. We can then create our SCPs attached to each of these OUs, denying, well, all CloudTrail, all CloudTrail actions. All right. Let's go ahead and move on with designing new solutions part 1. All right, so this will be our second module. We're breaking this domain up into 2 different parts because it is kind of a larger domain. So building and designing new solutions, we have broken this domain up into, well, 3 different subdomains: implementation strategies for reliability, ensuring business continuity, as well as meeting our performance objectives. So let's go ahead and dive right into, well, implementation strategies for reliability. Now, first off, of course, one of the really awesome things about the cloud in general is its, well, inherent scalability and reliability, the automation capabilities around its scalability and reliability. So when it comes to just some basic services to utilize this, we've got our EC2 autoscaling, Elasticache, SNS, CloudFormation, our Elastic Load Balancers, SQS, Kinesis, as well as Cloudwatch. All of these services can help automate our scaling as well as improving our reliability. Now, of course, using CloudFront for CDN, we can utilize CloudFront to allow very, very fast ingress and egress into Amazon's network, directing our traffic to our public load balancer, which will then, of course, evenly distribute all of requests across our healthy host. And in this case, we've got our auto-scaling group that can scale in and out with our live production needs or with our base compute requirements. As we add new instances into this auto-scaling group, those will automatically be registered with the load balancer, and our new requests being sent to the load balancer through CloudFront will be sent to the new instances. As we pull the instances, we can remove active sessions from that instance and redistribute those to other instances. So we have very, very simple automatic scaling with very little to no interruption or impact on our customers, on our users. So we also have Route 53 for DNS service, but also multi-geo routing. Route 53 can maintain health checks for all of our regions, or all of the regions that you provision, and detect a failed or unhealthy region. If a load balancer goes offline, Route 53 will stop sending requests to that load balancer and can instead fail over to a secondary region or to a static website or whatever routing policies we've configured in Route 53. Let's see here. Now, another just really best practice is when it comes to adding scalability into our application tier. We've got our load balancer that can sit in our public subnets. Load balancer can, well, span multiple availability zones in our region. So the request comes through the load balancer, and these requests can be evenly distributed to our application servers, to our web application servers in their own unique autoscaling group. Now in this scenario, we have a NAT gateway in both AZs as well. If AZ1 goes offline for whatever reason, if we have service impact in AZ1, the NAT gateway in AZ2 is still providing egress for our application servers. The load balancer will stop sending requests to the unavailable instances in AZ1 and instead direct all requests to our instances in AZ2. And our autoscaling group can then scale out and add additional instances to AZ2. So we have a loose coupled environment that does have high availability inherently built into this architecture. Now we can also create internal load balancers. So our web servers will redirect the request. Instead of tightly coupling our web servers to our application servers, we can direct our web server request to the application tier load balancer, which of course evenly redistributes these requests across our application servers in a private subnet. Now these are the application tier or internal load balancer is not going to be publicly accessible. By properly separating our tiers, we have independent scaling across each tier, but we're also enforcing security at each tier. Our application servers in this example are not directly accessible to the world. In fact, what we could do is actually place our web servers in a private subnet as well. So now the only publicly accessible resource we would have would be our load balancer. Now, if we want to further decouple, we can take advantage of asynchronous message processing with SQS. Our public tier instances, our web tier instances can send the message to an SQS queue. Our application tier instances can grab the messages out of our SQS queue, process the message, and then, well, return the message to our web tier if needed. This gives us decoupling, or further decoupling rather, of our app and web tier. Now keep in mind, of course, SQS, we have two different flavors of SQS, standard and FIFO. Standard queues, unordered at least once delivery of our messages, with our FIFO queue being first in, first out, but limited to 300 transactions per second. So throughput on our FIFO queues will be a little bit less than the throughput on a standard SQS queue. Of course, SNS gives us one-to-many or one-to-N message delivery. We can publish the message to our SNS topic, subscribing multiple SQS queues to this topic. Message sent to topic will be published to all subscribers. In this case, we are fanning out one message sent to an SNS service, which is then distributed across 3 queues. 3 worker nodes process these 3 different messages independently from each other. Very useful for fan out, batch processing of our messages. Excuse me. All right, we also have Kinesis Streams, once again for asynchronous tasks. This does give us a very simple way to, well, build in some, to collect, process, and analyze our data in near real time, potentially terabytes of data per hour, but also build in some at least once semantics into our stream and data processing. So I can have my my web tier generate data, send this through Kinesis, and have my application servers grab the messages from Kinesis with extreme throughput. So Kinesis can ingest our real-time data, our video, audio, application logs, click streams, telemetry data for IoT sensors, ML, analytics, just massive amounts of data with extreme throughput. If we want to look at kind of an example of this, we've got our Kinesis data producers that are generating our data points and sending this through our Kinesis endpoint. This will be pushed through the stream. We can then have our consumers on the right grab this data from our stream and process this data, transforming it, saving it to whatever, well, data store we need. So S3, Dynamo, Redshift, or even another Kinesis stream. So quite a bit of functionality and throughput. for huge amounts of data in near real time. Now, when it comes to comparing Kinesis data streams versus Kinesis Firehose, Kinesis data streams, well, this gives you the ability to set up custom processing for every incoming record. Sub-second latency, so extremely fast, near real time, with multiple frameworks or multiple stream processing frameworks available. Now, with Kinesis data streams, you do have a very, very large amount of throughput. You do have a lot of capability, but you also need to set up and configure your producers as well as your consumers. With Firehose, you don't have quite the performance, the processing latency of at least a minute. But it is far, far simpler to use. You don't need to utilize the KCLs or KPLs. With Data Firehose, we can, with very little to no administration, set up batch processing of massive amounts of data, sending this data to, whatever consumer we need. Once again, S3, Redshift, Elasticsearch. So very, very high throughput with very little administration with Data Firehose, but it is not real time or near real time, whereas Data Streams is near real time. All right, using SQS for our responses, we can go ahead and create queues in both directions. On the left, we have our initial producer generating a message, placing it into our first queue. On the right, we've got our initial consumer processing the message, or grabbing the message, processing the message, deleting the message, and then sending the response to a response queue, where the response will be kept in queue until we have a consumer here on the left that ultimately grabs, processes, and then deletes the message. This gives us, a higher guaranteed message delivery, at least once message delivery. We have multiple queues that we now have to manage, and we also need to set up and configure identifiers for our return messages. What message is this one responding to? All right. As far as utilizing S3, we know that S3 is our natively online object storage built for extreme durability. So I can have my users upload data. Instead of sending data to an application residing on an EC2 instance, I can have them send it directly into an S3 bucket, an ingestion bucket. We have multiple storage classes within S3, so I have very, very low cost, but extreme durability for my data storage. Remember, 11 nines of durability. Durability, durable, durably is kind of a key word on our exams for S3. Of course, I could also have the users connecting to an application on an EC2 instance, and the app could write that data persistently to attached EBS volume as well. It won't have the same durability as S3, but it is then immediately usable and fast by our applications. Now, utilizing CloudFront can potentially reduce our traffic cost and will improve our performance. By utilizing CDN with CloudFront, your users, regardless of where they are in the world, will ingest or will have data ingestion or data egress come through Amazon's edge locations. Now you can also restrict access directly to our S3 buckets to your S3 buckets, forcing your users to pull the data from CloudFront, which does give us a lot of built-in edge protections as well as DDoS mitigation. Now, as far as scaling with our EBS volumes and instance storage, EBS volume size can be increased while attached to an EC2 instance, dependent upon the type of volume we have, as well as the type of instance we have. We may have very, very fast I/O. Keep in mind, though, unlike S3 with our EBS volumes, it is pay for what you provision, not pay for what you use. So if I have a 16 terabyte EBS volume and I write 200K of data to that, I'm paying for 16 terabytes of data while only consuming 200K. In addition to that, our EBS volumes are not globally readable. They're only usable by the EC2 instance they are attached to. Now, when it comes to scaling in RDS, of course, we have a couple different options with RDS. We can increase our storage size, as well as increase the instance size and type. Now, as far as RDS storage, we can generally increase storage non-intrusively. Increasing our vertically scaling our RDS instances, however, generally does cause, well, some disruption. We'll have to modify the instance size, modify the instance type, and that will generally take the database offline for a small period of time. Now, with the case of multi-Z RDS, we can update the RDS database instance, and this will happen against the secondary as well as primary. So we can do this non-intrusively in our multi-Z RDS configurations. Another potential mechanism to scale our RDS databases would be, of course, to add read replicas. Now, if we're in a read-heavy workload, read replicas do offer, well, some form of horizontal scalability. We'll be directing our read request from the main RDS database into the read replica, offloading ideally as much read requests from the database as we possibly can. Keep in mind, of course, replication between our primary database instance and the read replica is asynchronous, and the read replica will have its own unique endpoint. Now there's a built-in Cloudwatch metric, replica lag, to show you how much lag you may have between your read replicas and your primary database instance. So this metric is useful for MySQL, MariaDB, as well as our Postgres read replicas. Now, we can also place or utilize a cache in front of our data sets. With Elasticache, we have a fully managed in-memory cache with support for Redis or Memcache. With Redis, we do have support for advanced data types, persistence of our data, automatic failover with our multi-Z deployments. Now it does offer horizontal scalability, once again with read replicas. You can scale up, but not out within our Redis clusters. Memcache, on the other hand, just very basic, simple key value storage for a simple, easy to set up performant cache in front of our databases. Once again, can scale both or scale up as well as out. And well, we'll scale out using multiple nodes. Keep in mind with Memcache, scaling out very quickly does perform a cache flush. So if you scale out too quickly, you may actually lose some data and then need to re-request and repopulate the cache. All right. Now with Elasticache, we can cache our most common requests. We'll set the TTL value or TTL value for this cache data. Requests for the data will be directed to the cache instead of directing the request directly to our RDS endpoint. If the data is present and the TTL or the age of the data is within the TTL limit that you've specified, the response is immediately returned to your application. If the data is not present or the TTL is expired, your application will then request that data set from the database, update the cache with that data set, and the TTL will start over. You can also perform write through, which will update the cache in line with the database. And in this scenario, your cache is, of course, going to have everything in the database. It'll also have the latest data sets. As your data set changes, the cache changes as well. But you are now also caching every piece of data. So you do have the ability to set lazy loading or write through when we're deploying your cache. As far as Dynamodb, this is our fully managed NoSQL database. So one of the important things when it comes to building and managing your databases or determining what is the right database, do we need a relational or non-relational database? Do we have ACID transactions? Do we have unstructured data? What is our performance requirement? What is our throughput and our concurrency requirements for our data set? Dynamodb, fully managed NoSQL database with extreme performance. Single-digit millisecond latency at any scale with no table size limits whatsoever. So with regards to a NoSQL database, you can stand up a Dynamodb table and with Dynamodb auto-scaling, your read and write capacity can also automatically scale up based on your active usage against the Dynamo table. Now, if single-digit millisecond latency is not fast enough, we can also place a cache in front of your Dynamodb table. You can place an Elasticache cluster in front, or you can also use DAX. With DAX, a couple different options: read through cache or write through cache. With our read through cache, excuse me, the request is sent to DAX. If it's not there, the request is then immediately forwarded inline to our Dynamo table. The response back from Dynamo will go through DAX. The cache will be updated as the response is returned back to your instance. With our write through cache, of course, we're going to update DAX, and DAX will update our Dynamo table on our behalf. So a couple different options. DAX does provide a very, very large amount of performance, so microsecond latency for our Dynamo tables. Once again, when it comes to database caching, we do want to be aware of how we are consuming the data out of our database. If our database is updating multiple times or very, very frequently, caching may not be the best option. For a read request, we need to be aware of, can our database or can our application afford stale data? If the answer is no, then once again, a cache may not be the best option. Of course, using SQS and Dynamo together, our application can make a call to our SQS writer app, updates the Dynamo table, or rather, the SQS writer app attempts to write to our Dynamo DB table. If this fails to write to Dynamo, it will instead place a message into SQS. We'll have a queue draining app, which will grab the message out of queue, and instead write that into our Dynamo table to guarantee that that update is present within our table. So if we do have a lot or if we've scaled up our DynamoDB table and we notice that it's costing us quite a bit, we can utilize SQS to kind of offload that and set our DynamoDB read and write capacity a little bit lower. SQS will guarantee that the updates to our Dynamo table will be successful, but it won't necessarily happen immediately. Now, we can also use DynamoDB within our EC2 autoscaling. So we can create a as we are updating and reading, or rather reading and writing to our Dynamo table, and our application pool is scaling out, we can create Cloudwatch metrics to monitor our provisioned read and write capacity as well as our consumed read and write capacity, enabling automatic scaling of our read and write capacity for our Dynamo table when needed. Final thing with Dynamo is our global tables. With global tables, we create a DynamoDB table, enable Dynamo Streams, and then, well, create replica tables across a different region. You'll select the region you want the replica table to be present in. When an update to one Dynamo table occurs, that update will automatically be reflected in the Dynamo stream for 24 hours and asynchronously be pushed to the replica tables in whatever other regions we've specified. Not only does this give us an actual backup of our Dynamo table, for global applications, we can then now utilize the same data set with a region-specific replica table. So lower latency for multi-region based applications. It also, of course, does act as geo-redundancy. All right, now when it comes to basic components of loosely coupled architectures, the general idea of a loosely coupled architecture is that any failure, as small or as large as possible, should have minimal to no impact on every other resource. So our load balancers do support two-way traffic with immediate request handling and immediate distribution of our requests across our healthy resources. SQS, our clients will pull our SQS queues, persistent storage, guaranteed delivery of our messages. Of course, as SNS publishes all messages to our subscribers, can set up SNS topics for bulk notification, as well as mobile push capability, not only for message delivery within our components, but also alerting you and your IT staff of any potential issues. Kinesis gives us scalable event streaming. You can read and track your stream position, track your utilization, track the messages through the stream. And of course, auto-scaling scales your resources up or down. Auto-scaling within our EC2 instances launches or terminates your EC2 instances. Auto-scaling within Dynamo adds or removes your read or write capacity. Gives you proper resource capability for while also lowering your cost when you no longer need that resource or those resources. All right, first question. An education company delivers course materials to their students as a PDF download. Recently, there have been more downloads than students in their classes. Uh-oh. And the company wants to limit each PDF to being downloaded to class members. The current architecture has students sign into a website that runs on an EC2 instance. The website provides links to publicly accessible files in S3. The company wants to use CloudFront to limit the downloads. What should we recommend? Well, this scenario actually sounds, or this question sounds like a really familiar scenario. Huh. So what are we trying to prevent? Well, we want to ensure that only the class members are downloading the PDF. We want to prevent or disable public access to these PDFs, and we want to enforce the use of CloudFront to limit and restrict our downloads. Well, that's a good requirement here. Possible architecture. Well, basic needs, of course, limiting downloads to class members, utilizing CloudFront for delivery, as well as S3 for our content storage. All right, so we've got our users coming in through Route 53 through CloudFront, logging into our application on an EC2 instance. We want to deliver the, the PDF from S3, but only to our trusted entities. So I have a couple different options here. Let's see here. All right, configure CloudFront with DynamoDB global tables is probably involved in the solution. Let's look at our possible answers. All right, write scores to a multi-AZ table in Amazon Aurora instance in the local region, replicating the score table among regions using Aurora Replication. All right, write scores to a Dynamo table in the local region and enable Dynamodb streams, create a worker tier to consume the stream and replay the data to a Dynamodb table in all other regions. Write scores to a Dynamodb table in the local region, creating a worker tier to read recent writes from the table and replay the data to Dynamodb tables in all other regions. Write scores to a Dynamodb table in every region directly. Remember I said there are sometimes some very obviously wrong answers. And write scores to a multi-AZ Elasticache Redis cluster in the local region. Write the code for the scoreboard to pull data from the Redis read replicas. Well, let's go ahead and kind of break these possible answers apart. All right, using multi-AZ table in Aurora, replicating a score data across multiple regions using Aurora Replication. Can Aurora replicate single tables? And how many regions can Aurora replicate to? So basic requirements are replicating entire database, not just a table, to just a secondary region. Not really going to be enough here. Second one, no, using DynamoDB. Let's see. DynamoDB is great for clickstream data. Yeah. Streams will synchronize their data between our global tables. And what is our data retention for DynamoDB streams? Well, we know it's 24 hours. So this does meet all of our requirements. C, using Dynamo tables in our local region, create a worker tier. Well, is a worker tier enough to replicate our DynamoDB tables and do so, well, with guaranteed replication? How much logic would be needed to identify and define what a recent write is, and how much overhead would be added to Dynamo throughput to do everything? It's not a very efficient option. So I don't really like this one. Oops. So yeah, it works, but there'd be a lot of work to configure, and yeah, it's going to increase our throughput fairly dramatically. All right, directly write scores to DynamoDB tables in every region. Well, once again, that's a lot of logic. If a new region comes online, we need to create a new updated Dynamo table in that region, update our logic to replicate the data to that region, and we're potentially going to have, well, not potentially, we will have latency, but varying degrees, unknown amounts of latency. So it works, it's just not a really good solution. And finally, write a scores to our multi-AZ Elasticache Redis cluster. Well, how will Elasticache move our traffic between our regions, and what are our latency requirements? So exposing our Redis replica or read replicas rather to the internet, now that's a security or potential security issue, and there's once again going to be some significant latency. Remember, with gaming, we want to have as minimal latency as possible. So option B is going to be really the best solution out there. Let's see, give me 1 second here. All right, question 3. We are working with a company that collects clickstream data from global web-based marketing campaigns. The system uses auto-scaling within EC2 instances behind an elastic load balancer. Data is stored using MySQL RDS. A single campaign lasts between 1 and 2 weeks. When complete, the tracking system is deleted to minimize cost. Quarterly, data from every campaign is moved to Redshift for aggregation, analysis, and detailed reporting. The company adopted CloudFormation to automatically deploy the application in any region. How can we ensure the CloudFormation template meets the customer's requirements? Selecting 2 answers. So this is our first multi-answer question, and you will, as I said, always see know how many answers you have to select. So single campaign between 1 and 2 weeks, with quarterly data sent to Redshift for analysis. We want to automate the deployment into any region with CloudFormation. So how do we use CloudFormation to, well, set this up easily? All right, basic requirements. As I said, 1 and 2 week campaigns, quarterly data moved to Redshift for BI, deployments must be automated utilizing CloudFormation. So we have a few different options here. We can use mappings and the find and map function to find the right AMI ID for the image ID attribute. Use conditions and the AWS pseudo parameter to find the right AMI ID for the image ID attribute. Make sure the RDS instance name is different in every region. Define IAM users with the right to create a CloudFormation stack in every region. And set deletion policy of snapshot for the RDS instances. Finally, set the stack policy with the effect, deny, action, update, and resource RDS. So we have a lot of different potential answers here. What do we think is the right answer? So answer A, use our find and map function to find the right AMI. Well, what are our mappings? This gives us the ability to deploy this CloudFormation template in any region with AMIs that are, well, relevant to that region. Can they be used to identify our AMI? Well, yeah. So this will help us deploy into any region. So A sounds like a really good answer. B, what are our conditions? And our conditions mappings, what is a pseudo parameter? Well, conditions, well, conditions are not really in any way, shape, or form really located or relevant to mappings at all. I could set conditions if region A used this, but that's a lot of logic. It could work, but that's not a very well-built template. That's not a really good CloudFormation template. That is probably going to cause more problems than it solves. Make sure the RDS instance name is different in every region. Well, how is that going to affect it? Our RDS is global. Do we care about the RDS instance name? No, not really. So the RDS has nothing to do with our CloudFormation templates, and yeah, RDS instances having the same names in different regions will have no bearing whatsoever. So C is kind of out there. Define IAM users with the right to create CloudFormation stack in every region. Well, IAM is a global or globally scoped. So yeah, once again, this is just wrong. Let's see here. Creating a deletion policy of our snapshot for the RDS instance. Well, what happens when a CloudFormation template is deleted? What does the deletion policy do? And how does this benefit us? So creating a deletion policy of snapshot for our RDS instances, yeah, we might tear down the instance via CloudFormation stack delete. But with this deletion policy, we're then creating a snapshot of this RDS database before it's deleted. Once the snapshot's created, I don't care about the data. Remember, the campaign is 1 or 2 weeks long, and that's it. As long as we have some backup, I don't want to pay for that RDS database. So this actually sounds pretty good. And finally, set a stack policy with effect, deny, update, or action, update, and resource RDS. So this is going to stop, well, stack updates, but not stack deletion. So this is not even doing what we wanted to do, even though part of what I want to do is still remove that RDS database when I'm not actively needing it. So the answers A and E. Hoping everyone got that one. Use mappings in the function find and map to find the right AMI ID for the image ID attribute for the region the template is deployed into. With the deletion policy of snapshot for RDS instances, we can then deploy our infrastructure in an automated fashion for the campaign. When the campaign is completed, we perform a stack delete and get rid of all of our resources while maintaining our RDS snapshot. And final question here. We have a client that has an application with components written in various languages, including Ruby, Node, and PHP. Data is stored in a RDS MySQL database. Logs from the components contain different fields and information. Your task is to centralize the logs and use them to produce a coherent weekly report of usage patterns. What approach should we take? So breaking down the question, well, we need to take logs from our components, captures various fields and information from these logs, place and track the logs centrally, creating a weekly report of our usage patterns from these logs. So, well, architectural requirements. Oh, that slide's out of date. Well, we're going to ignore this slide because that's from question 1. So we know that we need to aggregate our logs, parse the logs, and create weekly reports for our log or from our logs for the week. Hey, use simple workflow service to move logs from Redshift or into Redshift. Query your Redshift using various BI tools. Have each application component store its log in Kinesis. Move the logs into Redshift in real time. Query Redshift using various BI tools. Have each application put its log into S3. Process the logs using EMR and store the results in a Redshift cluster for long-term analysis using various BI tools. And finally, use data pipeline to move logs from the application servers into an EMR cluster once per week. Process the logs using EMR and then store the results in Redshift for long-term analysis using various BI tools. A couple options. Looks like we've got a lot of Redshift options, so let's go ahead and look at the first potential answer. Simple workflow service moving our logs into Redshift, which we'll then just query. So how much is coding be required to move our logs into Redshift, and do we have any of these components in a private subnet? So simple workflow could be used, but it's going to take a lot of coding, and it's going to need to communicate, or we'll need to set up access for simple workflow to communicate with our servers. Any private subnet resources will need to code in that that access. This is a lot of additional work, not really the best option. All right, sending our application logs through Kinesis. Well, let's see here. Is Kinesis appropriate for sending our log data? And well, is Redshift really designed to ingest data in real time? So it's not really designed for continuous ingestion of our data. Now, using Kinesis, let's say Kinesis Firehose to move our data into Redshift, that would be a potentially decent option because it will actually perform our copy and properly optimize the data stored in our Redshift cluster. But that's generally for a once our initial movement of data into Redshift. Continuous movement of data into Redshift will perform multiple copies, which is just going to make our Redshift constantly have to resort, and it's going to be expensive and unusable during this time period. So not really a good option. Let's see here. Answer C, is S3 good for log storage? Can EMR effectively and efficiently process our files, and is Redshift a good tool for BI? Well, yes, yes, and yes. So this does actually meet all of our requirements. We have secure, durable, low-cost log storage, EMR to pull the data out that we actually need, placing only that data into our Redshift cluster, and allow our reporting off that. And the final potential answer, can data pipeline move data between or to and from our on-premises server with weekly log collection? And what happens to logs and instances that are created and terminated via autoscaling? So a couple just very potentially significant issues with this possible answer. Weekly log movements, not really sufficient. And during that week, if we add or remove instances, logs from those instances are gone as well. So yeah, we will be losing data. This does not meet the basic requirements, which does, of course, leave us with C. Have each application put its log into S3, process the logs using EMR, storing the results in Redshift for long-term analysis using whatever BI tools we want. All right. That does bring us right up through the second part of building new solutions. That being said, I've been chatting here for just over an hour and a half. You all have been listening. Thank you for that. Assuming the questions have been coming in, I'm going to go ahead and throw a quick 10-minute timer up, give us a chance to stand up, refresh our coffee, drink some water, and we will come back in 10 minutes. Oops. And because I love this timer, we are going to go ahead and race some monsters. So in 10 minutes, we'll come back and get started with the next section. I'm going to go ahead and hope for the Stay Puft Marshmallow Man. Oops. All right, welcome back, everyone. Hopefully you all had a chance to refresh your coffee, grab some water or whatnot. I know I did. So we're gonna go ahead and continue with domain 2, developing new solutions, the second part. So in this module, we're breaking up part 2 into 2 subdomains: security requirements and controls, as well as deployment strategies designed to meet whatever business or changing business requirements we have. So first off, as far as identity and access controls, of course, we have IAM. We have our IAM users, groups, roles, or policies. We have STS for temporary access. And this can help authenticate and authorize our users. We've got our service roles that we can assign to our EC2 instances, to our Lambda functions, to define which users have access to these resources. And of course, identity providers, where we can one of the key principles, regardless of which domain we're operating in, is follow the policy of least privilege. Now, tagging gives us a very simple way to identify our resources, to build, duplicate, or replicate our existing resources, and do so following best practices, rebuild them or redeploy them idempotently. And well, we want to monitor, send alerts when our instances become unhealthy or shut down, are improperly tagged, or are just built not following the rule set that we've created. So let's go ahead and dive into your first question here. Your customer's on-premises monitoring system currently receives performance notifications from local management systems and data from agents installed on our on-premises operating systems. The customer wants to use this existing on-premises monitoring system to monitor EC2 instance performance and state changes of all of your EC2 instances. What should we do to monitor EC2 instance state changes and performance? Well, breaking this down, we've got an existing on-prem solution that we want to continue using on our EC2 instances. We need to set up notification for any state changes of our EC2 instances. And how can we do this? So possible architecture. Well, we've got a monitoring system on premise. We can set up and enable EC2 performance monitoring and set alerts for our EC2 state changes. All right. So first one, configure Cloudwatch alarms for relevant EC2 actions. Have the alarms send SNMP traps to your monitoring systems. Configure more Cloudwatch alarms for high CPU and high network throughput. Send the notifications to our monitoring system. All right. Configure Cloudwatch events rule for EC2 instance state changes. Have the events rule trigger a Lambda function notifying your monitoring system. Pull Cloudwatch metric data into your monitoring system as well. Install the Cloudwatch events agent on all CloudTrail events agent rather on all EC2 instances. Configure CloudTrail events rule in AWS config for EC2 instance state changes. Trigger a Lambda function that notifies the monitoring system and pushes metric data from CloudTrail into your monitoring system. And finally, configure a Cloudwatch events rule for API calls for all EC2 operations. Have an events rule trigger a Lambda function that notifies your monitoring system, pulling Cloudwatch metric data into your monitoring system. All right, well, a couple answers. Some seem plausible, some seem not. Let's go ahead and dive into these potential answers. So answer A, can Cloudwatch alarms be triggered by metrics such as CPU percent, our network throughput, and are Cloudwatch alarms triggered by our EC2 state changes? Well, unfortunately, no. So while we could set the Cloudwatch alarms based on our Cloudwatch metrics, state change is not a Cloudwatch alarm. The second one, well, Cloudwatch events for instance state changes, that actually sounds good. Creating an events rule to see our EC state changes and then have that trigger a Lambda function. That actually sounds, well, that sounds like a good idea. And we have to build a Lambda function now. It's not that hard. And there might actually be a pre-built function for that. I bet there is. Second one, CloudTrail events agent on all, I'm just gonna stop myself there. Is there a CloudTrail events agent? No. And can config get information from CloudTrail? Well, potentially, but we can create some config rules for CloudTrail events, but yeah, there is no CloudTrail events agent. And the final option, well, Cloudwatch events rule for API calls on all EC2 operations. Well, what does Cloudwatch events do? We can install the agent, but it's not going to capture our API calls. It will. Yeah, that's not really what the Cloudwatch agent would do. Cloudwatch events will capture our state changes, but these, if the instance is stopped, the agent's not running. So we're not getting any information. So it's not actually a really usable solution, which leaves us with B, where we set up Cloudwatch events rule for EC2 instances or instance state changes with the rule triggering a Lambda function. Cloudwatch metric data pushed into our monitoring system. Proposed solution will look kind of similar to this. All right. Question 2. Your customer runs a mobile pet minder application that needs to be re-architected to run on AWS. Oh. The backend receives pictures every 10 seconds from source cameras and updates the end user's mobile app with the latest picture of their pet. Pictures are not stored. They are either delivered or deleted when the next picture arrives. The customer wants to make sure of 3 things. Only their customers can access the pictures, the service can cope with sudden large peaks in load, and the service is highly available. So what option meets all requirements? Breaking this down, we need to ensure our pictures are not stored, they're delivered or not. If they're not, we delete them. We need to ensure that we have some form of security in this, and scalability and high availability. All right, fairly simple. So possible architecture here, we've got our client accessing our application user login. We need to ensure that we have scalability in the application, and it has to be highly available. All right, so a couple options here. We can use Cognito for mobile user sign-in, use an auto-scaling group of EC2 instances across multiple AZs to serve the images, Elasticache with Rds Replication group to cache, and multi-AZ RDS to store the user information. All right, we can use Cognito for mobile user sign-in, RDS instances across multiple AZs to serve the images, and an Elasticache cluster with Memcache replication. Use Amazon Web Identity Federation for mobile user sign-in, an auto-scaling group of EC2 instances across multiple AZs to serve the images, and Amazon Elasticache cluster using Memcache as a caching layer and multi-AZ RDS. And finally, create IAM users for the app. Use Cognito to map policies to the IAM users, caching identities across AZs. Use an auto-scaling group of EC2 instances across multiple AZs to serve images, an Elasticache cluster with a Rds replication group to cache, and multi-AZ RDS to store our information. That was just a really big mouthful of text on answer D. So let's go ahead and dive into these questions. Question 1, now, can Cognito be used for a mobile user sign-in? Yeah. Our replication or Rds replication groups highly available? Yeah. And can RDS be deployed into a multi-AZ configuration for high availability? Once again, yes. This does look like it meets most of our basic requirements for availability and scalability. Second option, should our images be served from RDS, and is Memcache highly available? Well, sadly, the answer to that is no. Memcache is not highly available, and no, we really don't want to deliver our images from RDS. Remember, we also want to delete these images. Yeah, so it just doesn't make sense. C, this is where we get a little fun. It's more cost-effective to build out a web identity framework or use Cognito. And let's see. Yeah, we're also losing some high availability as well with, well, once again, Memcache. It's just not really a good idea. A lot of work. I suppose it would kind of work, just doesn't meet our the requirements outlined in the question. And finally, answer D. This one just made me laugh. Hopefully you didn't hear that. Is using IAM users for application a best practice? No. We'll quickly run out of application users and max out our IAM, the maximum amount of IAM users possible. In addition to that, storing our user information using RDS, it's just, no, not really a good idea. 5,000 IAM users, and yeah, we don't want to store our user information because, well, it wasn't a requirement. So basic solution A, we can use Cognito. Our users will log in, be redirected through the load balancer to their instance where we can grab the image of their pet. They can see the latest image or the previous image if the latest image failed to be delivered. All right, question 3. Last night, your customer migrated their public website to AWS after suffering a major data center failure. Due to the urgency of the move, the customer's operations team did not implement a load balancer or an auto-scaling group. The 2 web server instances have elastic IP addresses, and their DNS provider returns both IPs when queried. This morning, the website was the target of a malicious login attempts from about 10 IP addresses. Which solution Best offers quick and easy protection for the site from these malicious login attempts. Now, a couple things about this possible question. Breaking this down, well, we didn't, unfortunately, due to the very nature of this migration, did not actually complete the migration in the best manner possible. We are now being attacked. We need to protect ourselves from this attack, but this is not a long-term solution. This is a quick Band-Aid fix to get things up and running. We need quick and easy protection for the site. So, no load balancer, no auto scaling. We do have elastic IP addresses that are returned on a DNS query, and we have about 10 different source IPs sending traffic through to these two elastic IP addresses. All right. Luckily, it's small scale. So let's build our Band-Aid here. Implement a web or AWS web application firewall tier from the AWS marketplace with load balancers in front of and behind the WAF tier. All right. Move the customer's DNS provider to Route 53 and implement a WAF rule to block the malicious IP addresses. Create a new security group and only allow access from a predefined set of addresses. Add the security group to the web server instances. Or create a deny network access control list, or network ACL, for the known malicious IP addresses and associate it with the subnets containing the web server instances. Now, I kind of like this one because what we're doing is not the end-all be-all fix. This is, in fact, a Band-Aid. But let's go ahead and dive in. Option 1, implement a WAF and a load balancer in front of our instances. Well, yeah, WAF, there's such a thing as a WAF, but this is going to take time to set up, configure. We'll then have to adjust our DNS. That can take time as well. So it works, and this is something we want to look into, but time is the factor. We need to stop this now. So it's not really the best answer. Move the customer's DNS provider to Route 53. Once again, use a WAF to block our malicious IP addresses. Well, once again, we've got some time constraints. Route 53 doesn't prevent DDoS attacks. We could set up some additional protections here, but it's not outlined in the possible answer. This doesn't, well, it doesn't meet our time constraints, but it also doesn't potentially solve the issue. And finally, or C, add a security group. Well, what is a security group? If I create a security group and allow only access from predefined set of addresses, add the security group to the web server instances, yeah, I could do that. But what if I have a valid user coming in from an IP address that's not one of these predefined IP addresses? They're going to get blocked. So while this is not a bad idea, it's going to cause more problems than it solves. In addition to that, it's not really the best idea. Ignore this slide. I think that is not really relevant to answer C. In answer D, create a deny network access control list for the known malicious IP addresses and attach it to the subnet. Well, this actually works. Security groups give us the ability to allow traffic in. They're stateful, so if I allow it in, the outgoing response is automatically allowed. Network ACLs, on the other hand, we can set up what traffic is allowed in. We also have to set up what the traffic is allowed out because they're stateless. But the real power of network ACLs is they also give us the ability to create our deny policies. So if it's only 10 IPs, yeah, I can block all 10 of those in a network ACL. And this is a quick 10-second solution to stop this attack. That's, once again, not the best solution. This is a Band-Aid fix, but it does work. So we create our deny network access control list with the known malicious IP addresses associated with the subnets containing our web server instances, and then we probably want to re-architect this and actually make it secure. So here we have our proposed architecture. We've got our public subnet with our network access control list. And finally, customer runs an event management SaaS application that uses EC2, autoscaling, elastic load balancing, and RDS. Software is installed on instances at first boot using Puppet and Chef, which is also used to deploy software updates multiple times per week. A major software overhaul, a new, much larger version of the software has been deployed to running EC2 instances, and some of the instances are being terminated during this update process. What actions could be taken to prevent instances from being terminated during the updates? Once again, select 2 answers. So breaking this down, keep in mind we do have to select our 2 answers. So we need to stop our instances from being terminated during these updates. We have a large update package. And we just need to ensure that the update is being pushed successfully to all instances. So, couple things. When we think about this question, what's going on? So why are instances being terminated? And or what has to happen to prevent our termination during these updates? So we have to realize, well, what's going on here? Do we have a bad actor? Is this a systems issue? Or is this some level of automation that we've already configured? Let's look at the possible answers. Use the zero downtime features of Elastic Beanstalk to deploy new software releases for your existing product. Use code deploy to create an application and deployment targeting the autoscaling group. Use code deploy to deploy and update the application. Suspend the autoscaling process. Once suspended, deregister the instance from the load balancer, update the application, and register it with the load balancer on a successful update. Use the management console to enable termination protection for the current instance. And finally, run AWS autoscaling detached load balancers before updating your application. All right, so we got a couple options here. Some of these sound good, some of them sound plausible, and some not so much. Let's go ahead and look at this. All right, option A, use the zero downtime feature of Beanstalk. Oh, zero downtime feature of Beanstalk or blue-green deployments. This would add a new instance and update that new instance and then swap DNS to the new instance. But that's not really what we're doing here. That creates new instances. It's not going to update our existing instance. And we're not using Beanstalk. We're using Puppet and Chef for these updates. It's not really plausible. Use code deploy. So creating our application and deployment targeting our autoscaling group. Code deploy to deploy and update the application in the future. Well, I kind of like that. Can code deploy remove an instance from a load balancer? And well, can it suspend health checks? Well, yeah, we do have the ability to set up different tasks inside code deploy. So we can run our pre-installed task, removing it from the load balancer, suspending health checks, and once this is done, then starting the update. We can then validate the update before restarting health checks and adding the instance back into our load balancer. So I like B. Suspend the autoscaling process. Once suspended, deregister the instance from our load balancer, update the application, register it with the load balancer and successful update. Actually, I like this one. This is another thing that might cause termination of our instances. If the instance becomes unavailable and fails a couple load or autoscaling group health checks, well, the autoscaling group is going to remove it. So that will stop that. We can now perform our update fear-free of incidental or accidental termination. All right, termination protection, that absolutely has no bearing whatsoever. That's not a user terminating our instances, it's the autoscaling group. So our users can't terminate the instances, that's great, but the autoscaling group still can. And finally, AWS autoscaling detached load balancers before updating our applications. If we detach the load balancers, well, we're going to stop all traffic to all instances in our autoscaling group. It's just not really a good or the best idea. So B and C together will give us the ability to perform these updates quickly without terminating our instances and adding new ones. We'll update the app and that'll be that. Oops. All right. All right, tell you what, I'm gonna go ahead and we've got 10 minutes to, or I'm 10 till, I'm gonna go ahead and do another quick 10-minute break before we run through our final domain, improving our architectures. So 10 minutes, we'll come back at, I guess, 1 after 1 o'clock. All right. Go King Kong. Let's see. Oops. All right. Module 6 is going to focus on part 1 of improving our architectures. And of course, we've broken this this module up into 3 different subdomains: troubleshooting, understanding and planning how we can improve our existing solutions for operational excellence, as well as reliability. So in this module, we will be focusing on, or in this domain rather, we're going to start really focusing on the well-architected framework and building around it. So when it comes to troubleshooting on AWS, luckily, troubleshooting in AWS is usually fairly straightforward. A lot of different log generators, a lot of different mechanisms in place to help understand what actually went wrong. Now, understanding how to use these, where they are, when to use them is going to be kind of important. So we have our S3 server access logs, can help us troubleshoot bucket access issues, data requests. I made a request to S3 and did not get a response. Of course, our load balancer access logs can analyze our traffic patterns, troubleshoot network issues, any traffic going through the load balancer, source, destination, IP, latency, server response, all of this can be captured there. So useful. CloudTrail, of course, will capture our API calls. Who is doing what, when, and where the request was being made from, what the response was. So a few different options here. Next up, we've got our VPC Flow Logs, even more so than our load balancer logs. This will give us full network logging, everything in the VPC. So all IP traffic going into or out of our network interfaces, our subnets, our resources within the VPC. Quite a lot of networking information there. Such it might be a little much information to capture. We've got our Cloudwatch logs. Of course, we can set up and enable metrics, monitoring, troubleshooting our operating system applications. With our Cloudwatch agents, we can build our custom Cloudwatch metrics and gain quite a bit of information as to what's going on within our account, within our resources. And finally, of course, we have config. Now, config can be used just as a change management platform, but we can also set up config rules, giving us continuous monitoring, continuous assessment of everything in our account. Config will alert us if we have any rule violations, what the violation was, what resource, who launched it. So it's rules as simple as every resource must be tagged. I can identify allowed or not allowed EC2 instance types, or I can build my own custom rules with alerting or automated remediation of these rule violations as well. So a lot of just basic built-in and ideally automated troubleshooting capabilities within AWS. Let's go ahead and get to our first question. All right, your client's Cloudwatch logs configuration receives logs and data from on-premises monitoring systems and agents installed in operating systems. A new team wants to use Cloudwatch to also monitor EC2 instances performance and state changes of the EC2 instances, such as instance creation, instance power off, and instance termination. This solution should also be able to notify the team of any state changes for troubleshooting. What should you do to monitor EC2 instance state changes and performance? Well, let's go ahead and break this question down. All right. So we know Cloudwatch is receiving our log and data from our on-premises monitoring systems. We want to use Cloudwatch to monitor our EC2 instance performance and state changes. How can we configure this? And I love this next slide. Remember, some of our questions, and not some, I don't want to say a lot of them. So you will occasionally see questions like this, where this first sentence has no bearing whatsoever on the requirements, on the questions, or the potential answers. It doesn't matter. We could drop this out entirely and it would make no difference to the answer. When you see these types of questions, don't get caught up in the fact that we've got our on-premises monitoring systems. It doesn't matter. So, possible architecture here. Well, We know we want to use Cloudwatch. That was one of the basic requirements. We need instance monitoring, performance and state change, as well as automated notifications. That's pretty simple. We've already looked at a couple examples similar to this question. So, well, let's see here. We can configure Cloudwatch alarms for the relevant EC2 state changes, have the alarm send SNMP traps and metric data into our Cloudwatch dashboard. All right. Configure a Cloudwatch events rule for EC2 state changes, having the events rule route to an SNS topic notifying your client. Kind of like that one. Configure a Cloudwatch events rule for API calls for all EC2 operations. Have the events rule route to an SNS topic notifying your client. That sounds, if that works, that's awesome. Install Amazon Inspector agents on our EC2 instances and have the agents report instant state changes and performance data via Cloudwatch logs. Okay. Well, let's go ahead and dive into these a little bit. So first thing, Cloudwatch alarms for the relevant EC2 instant state changes. What is a Cloudwatch alarm? What triggers our Cloudwatch alarms? How do we set them up? Cloudwatch alarms are based on metrics. Metrics, not state changes. So A is wrong. B, set up our Cloudwatch events rule. Well, we've already talked about Cloudwatch events rule. That captures state changes. I can have my state changes trigger SNS topic and that notifies our client. That seems to meet, hey, there we go. It matches all of our requirements. I like it. Configure Cloudwatch events rule for API calls for all EC2 instance operations. Oh, I think we've already talked about events rule and we understand that it can trigger on API calls, but it's not necessarily going to be great. What happens when anything other than an API call causes our state change? So application locks up or a user logs into the instance and does a shutdown now. Well, that's a state change, but it's not going to monitor or give us every state change. That's not necessarily the best option. All right, install Amazon Inspector agents on our EC2 instances. Have the agents report instant state changes and performance data via our Cloudwatch logs. Well, we can install the agents. We'll get some performance data, but it's not going to capture our API calls or state changes. And of course, if the instance is stopped, well, the agent running on said instance won't give us any new information like instance startup or termination. So doesn't capture enough information, doesn't meet our state change monitoring requirements, which leaves us, of course, with option B. We'll just set up some Cloudwatch events, trigger SNS notification for these events, and alert our client, which is kind of what we thought. All right, our next subdomain, let's go ahead and determine and build strategies to improve our existing strategies for operational excellence, which is, of course, the fifth pillar in our well-architected framework. So the basic guideline of the operational excellence pillar is, well, understanding what our business and customer needs are, making frequent, small, reversible changes, and continuously improving, striving constantly to improve processes, procedures, builds regarding the other four pillars of the well-architected framework. Constantly making improvements, identifying areas of how we've prepared our infrastructure, what and how we are operating, and how we can potentially evolve to improve the architecture or the infrastructure as a whole. So, a couple tools that can help us in preparing. Of course, we have Trusted Advisor, CloudFormation, and Systems Manager. Trusted Advisor can, well, help us build and define or understand our operational priorities. Trusted Advisor has a lot of free checks built in around the well-architected framework pillars: security, performance, fault tolerance, as well as cost controls. CloudFormation can help us design for operations. We can, well, build in infrastructure as code, idempotency into our infrastructure management. And of course, Systems Manager, well, this gives us a way to manage all of our system resources, insight, inventory, patch management, maintenance windows, run command, connection manager, all different tools that can help us make whatever automated changes we need to. All right, and as far as operation, Cloudwatch and Lambda, so we can view our operational health, and Lambda we can set up and enable automatic remediation regardless of what the event is. And as far as evolution goes, well, we have Elasticsearch, we have code commits. Well, these two might kind of be a stretch, but one of the general premises of the operational excellence is making small, small, frequent, incremental changes based on the needs that we've identified. So using Elasticsearch, we can use Elasticsearch to understand how we've built our resources and any areas where we might need to improve. We can search through that and look for deviations, code commits, can share our learnings, libraries, scripts, documentation in a secured versioned repository that allows us to, of course, update these learnings, these libraries, these scripts, these documentations as needed as our platform evolves. So question 2 of 3. Your client uses Kibana to create dashboards and visualizations of their on-premises environment to benchmark the health of their systems. They use this information to reactively respond to events when needed. They also want to use Kibana for all of their AWS VPC and Amazon EC2 log data, but require an automated means of responding to events in the cloud. Which solution would meet the requirements set by your client? All right, well, breaking this down, we know that we need to use Kibana to give us visualization into the health of our platform, our applications, our systems. We want to also use Kibana to, track our VPC and our logs, our VPC information, EC2 log data, and set up automated response. So potential architecture here must, of course, support Kibana. We need to gather all log data for operational health and enable automated or automatic response to any particular event. So a couple different options here. We could use Inspector to gather logs and Lambda for automated responses. Ingest data into X-Ray to build dashboards and visualizations. That sounds awesome. I like that answer. I hope it works because that would be really neat, right? We could use Cloudwatch logs to gather logs and Lambda for automated response. Ingest the log data into Kinesis data analytics. Cloudwatch logs to gather logs, Lambda for automated response, ingesting the log data into Athena and use its built-in support for Kibana. Or use Cloudwatch logs to gather our logs and Lambda for automated responses, ingesting our log data into Elasticsearch with its built-in support for Kibana. All right. Joking aside, while it sounds really great, doesn't really involve how some of those services work, or at least how X-Ray works. Kinesis data analytics, well, we can ingest the logs into data analytics, but that's not really, usable with Kibana. So a couple things. So Inspector. So we can grab our logs from our operating system, from our EC2 instances. We can use our Lambda for automatic response. Ingesting our log data into X-Ray, that's trace data. That's building a service map of our applications. So it doesn't meet the desired log data and Kibana requirements and won't really work in this scenario. Let's see here. Can Cloudwatch logs be used to collect logs from our instances and Vpc Flow Logs? Not really. I mean, we'll have some metrics. Kinesis Data Analytics, serverless solution for analytics in real time. Well, we could send the log data there. It doesn't really use Kibana, which is a basic requirement. Next up, Athena does not have support or a plugin for Kibana. So once again, Kibana is being the determining factor here. That leaves us with D. Sometimes ruling out all the wrong answers is correct. D, well, Elasticsearch does have Kibana support, so it does meet all of our requirements. So proposed solution, here we go. We've got our Cloudwatch logs, gathering the metric data, Lambda for automatic remediation. We can push all of our log data, all of our VPC flow logs into Elasticsearch with our Kibana plugin. Our client can use the same exact platform to monitor everything going on within their AWS account. Now, the final subdomain in this module is, of course, focusing on reliability. How can we improve the reliability of our existing solutions? So when it comes to continuous operations, we need to understand a few different things. With regards to high availability, what is our fault tolerance and what is our recovery patterns? Do we actually have high availability with fault tolerance, or do we just have fault tolerance? What is our DR plan? What is our RTO and our RPO, or recovery time objective and recovery point objective? How much data can I afford to lose? How much time can I afford to be offline? And how can I improve this? Or even in some cases, is it worth paying to improve that? So when it comes to architecting for high availability, we know right off the bat, we know we need to provision into at least 2 availability zones. 2 availability zones with an auto-scaling group and a load balancer gives us high availability and fault tolerance. If we have service impact to one availability zone, the other availability zone is likely not affected. Therefore, business continuity continues. We're able to operate. So what is your level of availability? We need to understand what your SLA is and design around that SLA. Now, ultimately, high availability does mean you will be adding more infrastructure than what you're actually needing. So it does cost more money. It also increases your architectural complexity. Because of the cost increase for high availability, it's very important that you understand just how much availability you require and build around that. Don't shoot for the moon. Northern Virginia has 6 availability zones. If I have 10 EC2 instances in all 6 EC2 or availability zones, that's 60 EC2 instances that I pay for. Is that necessarily more highly available than 10 EC2 instances in AZA and 10 EC2 instances in AZB? No. 60 EC2 instances versus 20. If something happens in Northern Virginia that takes out more than one availability zone, chances are it's probably going to affect all of them. So all that's doing is, well, driving up my infrastructure cost from 20 to 60, and that's just not a good idea. All right, so understanding how we can failure or what resources can fail and how we can respond to these failures. Auto scaling groups, EC2 instance auto recovery, Route 53 resource record sets, alternate domains, DR. With regards to our databases, multi-AZ RDS, of course, snapshots of our databases, EFS for shared storage, and of course, replicated Elasticache, replication within our Redis Elasticache clusters. Building for peak load. So again, automating our recovery steps, utilizing our auto scaling groups. Be aware of scaling, setup scaling. What is our capacity constraints? What's our min, max, desired capacity? How long does it take auto scaling to add a new instance? Building that into our scaling policies so we do not hit our peak load while we're actually scaling out. And of course, architecting for availability zone failure within our databases, using multi-AZ services, creating full backups, using RIs for critical systems. If one AZ fails and other customers are provisioning the same EC2 instance type, there might be a lack of that instance type in other availability zones. So RIs will actually mitigate that. You will have that guaranteed capacity. Identifying all your AZ-specific services and understanding which are regional or global, understanding and building a proper DR plan, and, well, identifying and removing any potential single points of failure. All right, so final question in this subdomain. A company wants to use an existing VPC for one of their regulatory application workloads. VPC network traffic risks associated with the application instances communicating with unauthorized external host must be addressed. This new workload should not introduce any potential network bottlenecks or require application level configuration changes due to compliance requirements. So what architectural improvement would you recommend to meet our company requirements? It's kind of an interesting question. If we want to break this down, we've got existing resources. We have our VPC. We do have some highly regulated application workloads. Instances have been found to be communicating with external host in an unauthorized manner. We need to stop that, but we have some restrictions on what we can do. We cannot make application level configuration changes, and we cannot introduce any potential network bottlenecks. So while an easy, very simple fix to this would solve this, the lack of change the inability to make application level configuration changes make this a little more difficult. So possible architecture here. We've got an egress VPC network traffic that we need to control, but we cannot introduce any network bottlenecks and we cannot modify our application servers. So with that understanding, let's see here. We can configure an IDS IPS host-based solution that installs agents on the application instances to control our outbound network traffic. Configure NAT gateways in each AZ for egress traffic. All right. Leverage forward proxy servers for web and URL content filtering, and configure a proxy load balancer to distribute our network traffic from the application instances to a fleet of proxy server instances for egress traffic. Deploying inline gateway appliance in one of the AZs to direct egress network traffic from all application instances through the application for monitoring and threat management. And finally, create network access control list rules that only allow network traffic from originating from externally trusted resources and apply to the application instance subnets. Well, all right, we got a couple answers. Some seem really complicated, some far less complicated. Some would work, others would work, but won't work based on the requirements. So let's go ahead and look through these. What do we think the best answer is? All right, with option A, we do have to configure our IDS IPS host-based solution, installing that on our application instances. Now, third-party tool to control or manage ingress and egress network traffic. And well, is it elastic? Well, since it's installed on the instances, it's as elastic as our application servers are. More importantly, it's not modifying the application itself. We're installing an agent on the instance, not modifying the application itself. So it does actually match the requirements. Is it the best way or the easiest? Possibly not, but it meets the requirements set forth by our client. Next up, leverage a forward proxy server and web and URL content filtering, and configure a proxy load balancer to distribute our network traffic from the application instances to a fleet of proxy server instances for egress traffic. Well, one, that's actually going to require a lot of application level changes, which is not available, not an option. And adding proxy servers as an intermediary that might help speed up some of the network paths, but it might also cause some bottlenecks. We really this doesn't really work. Deploying inline gateway appliance in one of the AZs and direct egress network traffic from all application instances through the appliance monitoring or from monitoring and threat management. Well, once again, this sounds good, but this is introducing a network bottleneck. One AZ or an inline gateway appliance in a single AZ. That is a bottleneck. That is a single point of failure. And because we'd also have to adjust the application instances to point to that inline appliance, we're now having to modify the application, which is not an option. And finally, create ACL or network ACLs, only allowing network traffic originating from externally trusted resources and applying this to the application instance subnets. Now, remember, of course, our network ACLs are stateless. Well, I suppose I could create an outbound network ACL deny rule. That's not what's listed in this answer. So it doesn't actually do anything. It wouldn't stop, it wouldn't help. So the answer is IA. Configure our IDS IPS host-based solution, installing the agents on our application instances to control our outbound network traffic. Configure NAT gateways in each AZ for egress traffic and for high availability, with a proposed architecture that would look similar to this. We install our IDS IPS agent on our application servers. We've got our admin subnet, we have our NAT gateway, and we're maintaining high availability without modifying the application running on these instances. It will scale out along with the application server instances as much as needed. Let's see here. Now we could also set this up. Auto-scaling proxy fleet. let's see, or this is B. So creating our proxy fleet, I can't talk. This of course would require some application modification. C, this creates our network bottleneck. So we do know that A is of course the right, or was the right answer. All right. All right, part 2 of improving our architecture, our final module. In this, we've broken this down into 3 subdomains as well, focusing on security, deployment, and performance of our existing solutions. And we know that this is, well, pretty much the largest portion of, or the largest domain covered in this exam, so kind of important. So first off, improving performance. What are we focusing on here? Lower latency, increase or shorter response time, increased throughput, scalability, high availability, lower cost, a lot of options, a lot of aspects going into performance improvement. Now, when it comes to improving our S3 performance, well, we know S3 is extremely durable, it's very, very cost effective, and we can host, well, a near infinite amount of objects in our S3 buckets. Well, if the objects are hosted in S3, why not serve the content directly from S3? We can move our static content into our S3 buckets, enable CDN with CloudFront, that improves our performance, also enables caching. It also offloads more traffic, more requests to our backend compute resources, which generally cost more. With our EBS performance, well, what type of EBS volume do we have? Do you have a disk-based EBS volume? Maybe go to change that to an SSD-based. GP2 or general purpose EBS volumes, very useful, good mix of performance and cost. IO2, IO3 EBS volumes or provisioned IOPS EBS volumes for your high performance EBS or high performance input outputs. Now, if we do have our provisioned IOPS EBS volumes, make sure your EC2 instance type is optimized and capable of actually meeting that performance. It'd be a real shame to connect a provisioned IOPS EBS volume to, let's say, a T3 large EC2 instance type that, well, the instance is your bottleneck, not the EBS volume. For Rds performance, well, be aware of what type of our database instance you have. You can scale up your instance size, the type, as well as increasing and improving your storage. Now, you can always improve performance by scaling horizontally as well, adding read replicas, or even adding caches in front of your databases. By offloading your read requests, less traffic is sent to your database itself, meaning a smaller, less expensive database and a faster response time on the data points that are requested from the data store. Now, with regards to DynamoDB, be very aware of not just your read and write capacity units, your WCU and RCU. You can enable scaling, you can enable on-demand capacity, but ultimately, Dynamo performance is what will have a very large factor on that is your actual partition key. Did you name your partition key effectively, or do you have just a lack of entropy, a lack of variance in your primary partition key? You can take advantage of global secondary indexes or local secondary indexes as well. With sparse indexes populating your GSIs or LSIs with data sets that are only updated or consumed frequently. You can then query the GSI or LSI instead of the primary Dynamo table itself. Keep in mind your LSIs do consume your primary table's read and write capacity. You can offload read and writes through an SQSQ to handle massive spikes in requests to your Dynamo table. You can also take advantage of placing a cache in front of your Dynamo table. We have Elasticache. We also have DAX, which is our in-memory cache for Dynamo specifically. So it really depends on how much performance, but also, well, if you have huge spikes in your write request, SQS can help make or ensure that those writes are updated in the table. Now, it's not going to necessarily be performance, but it will, the writes will appear. So understanding your data, understanding how you're using and consuming the services is going to help determine what the optimal performance is for that resource. Now, finally, it comes down to building a loosely coupled system. Avoiding single points of failure, allowing your system to scale out and scale in as needed, using tools like auto-scaling, your load balancers, to ensure your compute resources are, you always have the correct amount of compute resources rather. SQS and SNS for decoupling, Kinesis for event streaming, for massive throughput, massive analysis. So we've already gone through a lot of these services. Properly using them and configuring them and loosely coupling your resources. You should be able to select any resource in your infrastructure and kill it, terminate it, turn it off without that really affecting, or any compute resource, I guess, without affecting your infrastructure as a whole. So, question 1. A company has an application that accesses a relational database tier and runs on several EC2 instances placed behind an application load balancer. This application will now be used with a read-heavy workload to make medical records accessible to multiple insurance companies. Due to the nature of the data, compliance requires data protection at rest and high availability, especially during sudden large peaks in load. What is the best solution to improve performance for the current architecture? All right. We have a couple things here. We know that we need data protections at rest. We know we need highly available data sets. It is a read-heavy workload, and we need to improve the read request in this read-heavy workload without sacrificing security because, well, it is medical records. So, proposed solution here. We can go ahead and set up our application instances. Well, we need to ensure that we have data protection at rest, high availability, and we want to improve our read performance. So a few just basic requirements here. Let's go ahead and look through some couple of options here. You can use an auto-scaling group for the EC2 instances across multiple AZs, configuring the database tier with Dynamodb Accelerator as a caching layer for the reads. Okay. Use an auto-scaling group for the EC2 instances across multiple AZs. You deploy an Elasticache memcached cluster in front of the database tier. All right. Or use a Redis Elasticache cluster in front of the database tier and configure write through. Okay. Use an auto-scaling group for the EC2 instances across multiple availability zones. Deploy an Elasticache Redis cluster in front of the database tier and configure lazy loading. All right, so we have a couple different options here. The first sentence across all of these answers is the same. So we have a few different options. We know, well, let me just see. Let's go back real quick. Relational database tier, that's right. So we know that, well, answer 1 is wrong. Dynamodb Accelerator or DAX. Well, that's not for relational database. Dynamodb Accelerator is for DynamoDB, not relational databases. So we can rule A out. B, deploy an Elasticache memcache cluster in front of the database tier. Well, Elasticache can be placed in front of the database, can be accessed by our application for reads, but memcached does that support encryption or replication or high availability? And unfortunately, no, it does not. So it won't meet our data protection requirements. We lose our HIPAA compliance, and it doesn't meet our high availability requirements. So we'd be fined on top of that. So we know that C or D. And now the only difference between C or D is write through or lazy loading. Now the thing is with write through, updates to the database will be updated or the cache will be updated as the database is updated. So we are effectively caching everything, but we will always also have the latest information. Now, unlike lazy loading, with write through, there is going to be a write penalty, but since the cache data is never stale, we don't need to focus on the TTL. So we will always have the latest, most up-to-date data in our cache, which meets all of our requirements. Now with lazy loading, we're only caching the data that's actually being requested, but there is a cache miss performance or read penalty associated with that. So it's not the most performant solution. While it would potentially improve their performance a little bit, in a cache miss, it's actually detrimental performance. So that does leave us with option C, Redis cluster with write through in front of our, in between our application tier and our data tier. And here's our proposed architecture. All right. All right, next up, we want to determine a strategy to improve the security of our existing solutions. So when it comes to security, of course, first and foremost, we have two things we want to always be thinking about. The first off is, of course, following the principle or policy of least privilege. I need to ensure that you only have access to resources that you absolutely need to access. Another very important component can ultimately just be broken down into the shared responsibility model. What are you responsible for protecting? What is AWS? What is Amazon responsible for protecting? Once you understand that fully for multiple services, now we can really focus on improving our security. So enforcing our data encryption of our data in transit, as well as our data at rest, improving our network security, setting up automated remediation to any potential security events. When it comes to restricting access, of course, our user policies will be our IAM as far as protection of our data at rest, automatic server-side encryption. Now with S3, we can enable server-side encryption in 3 different flavors. S3 or KMS managed encryption keys, where Amazon will maintain and manage your key material, or customer managed encryption. Now with SSCC or customer managed server-side encryption, you will provide the key material along with the object that you upload, flagging that as the key material, which will be used to encrypt that object. Subsequent requests to retrieve that object, you also have to provide the key material. Otherwise, that GET request will fail because S3 will not maintain a copy of your key material. With Dynamodb, we have automatic encryption of your data at rest, but you can also utilize KMS managed encryption keys. With Redshift, you can use KMS or HSM to manage your key material. EBS, you can encrypt the objects prior to placing them into EBS. You can also enable volume encryption, where every piece of data placed in your EBS volume will automatically be encrypted. RDS, dependent upon the flavor of RDS, you can use transparent data encryption or KMS encryption for your data at rest. And of course, the message is sent through SQS and SQS. SNS and SQS can also be encrypted with KMS. So a lot of just built-in encryption capabilities for most of our storage services. Now you can also, so enforcing automatic encryption of your data at rest is going to be very important. Now, enforcing encryption of your data in transit can also be very, very simple. Now, when it comes to encryption of your data in transit, we do need to realize what we're actually protecting against. Once a packet, if I'm here at my laptop at my house and I am connecting into an EC2 instance, once my request hits my load balancer, the load balancer sits in my VPC. What is my VPC? My virtual private cloud, which is my private network. So if I don't have a requirement for true end-to-end encryption, I can terminate the SSL connection at the boundary of the load balancer, passing plain text connections behind it. Now the load balancer can also re-encrypt with a private cert passing, well, SSL connection from the load balancer to the EC2 instance. So you have to be aware of, well, how much security, how much protections you need, where you're adding this protection, as well as any potential performance penalties associated with that level of encryption. So certs can be stored in IAM. We also have ACM for your public as well as private certs. Offloading decryption and encryption work to the load balancer will remove that performance penalty from your EC2 instance to a fully managed service. Of course, with CloudFront, we have SNI. We can enable SSL connections through CloudFront to the load balancer where they can be then terminated using ACM. And truth be told, one of my favorite services because it does make certificate management far, far easier. ACM is free for all of your public SSL certs. Can manage your certs, automatically renew the certs, and Amazon is a trusted cert authority. So this will make setting up, establishing, and automatically renewing your public certification or public certificates very, very simply, or very simple rather. And okay, finally, our network parameter controls. Be aware that we do have multiple options. We need to think of AWS network security kind of like different layers of an onion. We've got of course, our edge protections in place, but once you get into the VPC, the connection comes through the boundary of the subnet, where the network access control list will inspect the ingress and egress from traffic. The request will be sent to the EC2 instance. As it goes through the Elastic Network interface on that EC2 instance, it will be inspected by the security group, which is a stateful virtual firewall. So I can set my network ACL to allow traffic in on port 80 from anywhere in the world. I can set my security group on the ENI to allow traffic in on port 80 from anywhere in the world. If I connect into that instance on port 80, the network ACL will inspect the traffic, the security group will inspect the traffic and allow it through, and I will hit that server. It's important to note, security groups are stateful, network ACLs are stateless, which means if I allow the traffic in through the network ACL, I also have to ensure it's allowed out. If I allow traffic in on the security group, it's automatically allowed out. Now, what that means is if you get a test question that specifies update or answer rather, where you set the network ACL to allow the request in, but it doesn't say anything about allowing the response, that might not be the right answer. Whereas if you have a potential answer where the security group allow the request in, you don't need to worry about the response. It's automatically allowed. All right. So question 2, one of our clients runs free video streaming services on AWS. Videos are stored in S3 and distributed publicly via S3 URLs. The client is moving towards a paid subscription models. Videos should now only be available to paid subscribers. Also, this is since this will now be a paid content, security controls require videos to be encrypted at rest. What is the best way to meet this new requirement for the paid service? It's actually pretty simple. But what are we actually thinking about? If we break this down, we know we have S3 for our media storage. We need to ensure that we have encryption of our data at rest. We need to figure out the best way to provide access to our paid subscribers, but restrict access to everyone else. So if we kind of think about this, we've got our S3 bucket with restricted access, protected access to our media content that is encrypted at rest. And we will not allow public access to these resources or to this media content. So, all right. Option 1, use a Cloud HSM appliance cluster for data encryption. Create IAM users and groups to only provide the paid subscribers access to the videos on S3. All right. Use KMS to encrypt and decrypt videos. Create a CloudFront distribution, configure OAI for user access, and deny direct access to the S3 URLs. All right. Use SSC-C to encrypt and decrypt videos. Create a CloudFront distribution and store the encrypted keys in CloudFront so that only authenticated users have access. And finally, create a CloudFront distribution using SSL TLS encryption between the paid subscribers and CloudFront. Deny access via S3 URLs. All right, so hopefully you had as much fun reading these possible answers as I did. most of these sound just really awful and wrong. Let's go ahead and look at them. HSM, what is HSM doing? HSM doesn't actually handle our encryption. It generates and stores our keys. So it's not going to actually perform the encryption. And well, I suppose it is possible to create IAM users for all of our paid subscribers. Once again, this is failing to allow scalability of our application. But before we even get there, the HSM here is just wrong. It's not how we can use or how we use the HSM, and it fails to meet our data encryption at rest requirements. Use KMS to encrypt and decrypt our videos. KMS managed encryption keys. I'm not necessarily a fan of the wording of this, but that is entirely possible. Configuring OAI, that will restrict direct access to our S3 URLs. So yeah, that does meet all of our requirements. I like this one. This one just really made me laugh. Is server-side encryption with customer managed encryption keys a supported method within S3? Yes, it is. Let's rethink about this one though. If we configure this, you would have to set up your own key material to encrypt all of the media content. You would then need to provide said key material to every user who wanted to request said content so they could decrypt it and retrieve it. So this just does not meet our user restriction requirements. If we tried this, it would be a headache, a nightmare, and within a week, your key material would be publicly posted somewhere. And finally, create a CloudFront distribution using SSL TLS encryption between our paid subscribers and CloudFront, denying access via our S3 URLs. So first off, SSL TLS is encryption of our data in transit, not at rest. And if we block access via our S3 URLs, we're denying get access to S3. Well, no one can get it, even our paid subscribers. So not only does this not encrypt our data at rest, it's now ensuring that no one can access our S3 content, which leaves us with B, using KMS managed server-side encryption keys and OII to restrict direct access to our S3 URLs. In the end, our possible architecture would look kind of like this. We have SSC-KMS for all objects in our KMS or in our S3 bucket, OAI to ensure that only our paid subscribers are able to access their content through CloudFront and not directly through S3. All right. And the final subdomain, we are going to talk about how we can improve the deployment of our existing solutions, how we can speed up and manage the deployment, or more importantly, how we can automate the deployment with tools like, well, CloudFormation, with Code Deploy, Elastic Beanstalk, and OpsWorks, yes. So with CloudFormation, basic considerations, CloudFormation, we can build our template. I can run my template through CloudFormation. This will set up and configure all AWS resources exactly as defined in this template. I can deploy this. I can perform stack updates. I can create my change sets to view what changes will be pushed through. If I do perform a stack update, I can update my user data scripts to perform automation against my stack resources. I can undeploy and shut down my resources, ultimately deleting my CloudFormation stack, which will delete every resource that is managed and defined in this stack. Now, the best part about CloudFormation, one template, I can deploy this idempotently once, twice, n times with 0 deviations, 0 typos. So that's pretty cool. Code Deploy is another really useful tool for application deployment. Now, this is an agent-based tool. You install the agent on your resources where you want to deploy your applications onto. And the agent will communicate with the Code Deploy service to update or install your applications, deploying them or redeploying and updating them. Now, Code Deploy does not, unlike CloudFormation, it does not manage your infrastructure. It will not deploy the EC2 instance, make changes to the EC2 instance, but you do have control over different steps in between this deployment. So downloading the package, stopping the application, updating said application, validating the update, restarting the application, validation of that it's restarted before moving on. So code deploy gives you a very simple, once again, automated mechanism to deploy your applications. And because this is agent-based, I can install the code deploy agent across my EC2 instances, across multiple accounts, across multiple environments, prod, dev, test, across my on-premises data center, even into other cloud providers. If I want to use code deploy to manage my application updates across every platform that I utilize. Now, as far as undeploy, code deploy rather can stop the applications running on the resources, but it will not create, remove, or modify the resources. So if you have code deploy that's managing 100 applications across 100 EC2 instances and you remove those applications, you will then need to also delete or terminate those EC2 instances, or you will still pay for them. Now, Elastic Beanstalk, great tool to manage and deploy your applications. One of the real benefits of Elastic Beanstalk is you don't need to focus or worry about any of the underlying infrastructure. Beanstalk will interpret your code. You provide the zip file with all of your source code. It will unpack, interpret, and then build the resources required to run whatever code, whatever feature environment you've specified. Now, as far as Beanstalk basic considerations, you'll specify your Beanstalk environment, single EC2 instance, auto-scale environment, load balancers. You can make changes to your environmental configuration and automate those changes via EV extensions. You can have Beanstalk create RDS database for you for your application to interact with. You can then deploy your application, multiple application versions. You'll have one Beanstalk application, and you can have multiple environments within this Beanstalk application. You can deploy different versions and create aliases pointing to your different Beanstalk application versions. So I can have version 1.4, which is my prod version. I can deploy version 1.5, which is with a beta alias. I can deploy version 2.0, which is a test, and I can test these different updates and then perform CNAME swaps to push this update or to update rather the new version from 1.6 from beta to prod, and my users will actually move to this new version automatically with zero downtime. As far as undeploys, remove the environment, remove all of the resources within Beanstalk. Really, really simple to use, fairly safe, very easy, and the best part about Beanstalk is you don't necessarily need to have any existing AWS knowledge to use this. And finally, we have, I guess not finally, next up we have OpsWorks, which is fully managed Chef or Puppet. Now, with OpsWorks, you'll set up and build your different layers, create your lifecycle events, create your chef recipes, your chef cookbooks, Puppet manifest files for configuration, how you want to build, configure, deploy your application, your resources onto your instances. As far as deployment goes, you can deploy a new application, update your lifecycle events, build your custom recipes to make changes to the layers, application layer, your resource layers. You can build a load balancer layer, your database layer, and manage all of this in an idempotent manner. Of course, undeploy, you can remove the applications, and unlike code deploy, OpsWorks can delete instances, can delete the layers, can delete this defined stacks and resources that you've specified for that application. And finally, ECS, or Elastic Container Service. Now, ECS takes over cluster management for your containers. So you'll build your ECS cluster, define your build in your task definitions. This will handle scheduling, placement, as well as scaling of your container images across your host fleet. You'll define multiple tasks, what your launch configure or launch type is, EC2 or Fargate, has its own built-in service scheduler. So ECS will, if you have an EC2 as a launch type, will deploy your tasks, will deploy your services across the host instances, ensuring that oversaturation of resources does not occur. If you do have EC2 as a launch type, you will also then need to configure auto-scaling groups to scale out these host instances, registering those within your ECS cluster. ECS can then start moving the containers to these new host instances as well. It'll handle removal of the containers. So it's just a very simple way to fully manage your, well, essentially control plane operations for your container fleet. And final question. A company has been manually deploying package updates to all of their applications running on EC2 instances. Due to the increasing amount of management overhead, the company is looking for a solution to automate application deployment and updates. These applications are critical and warrant the least amount of downtime during updates as possible. Which solution provides the automation needed? All right, so if we break this down, we have multiple package updates across the fleet of EC2 instances that we really can't have offline. Now, we need to perform and automate these application deployments and updates with minimal, if any, downtime. So how can we automate this entire process? Let's go ahead and look through some sample answers, or potential answers rather. Let's see here. We can create a golden image from a custom AMI containing all of the required application package updates. I like that one. It's probably not right, but I like that answer and it requires a lot of work. We can modify the EC2 user data property in an AWS CloudFormation template and update the stack. Well, what is our user data? Well, this is additional scripting functionality that runs generally once the first time we launch a new instance. So I don't think that's going to work. We could use CloudFormation to create and deploy a Chef server, bootstrap to EC2 instances with the Chef client software. That could work. I guess my personal thoughts on this matter are seeping through on this one. I'm not necessarily the biggest fan of Chef, but that could work. Or we could use the update stack API call in AWS CloudFormation to update the stack with a new version of the application. All right. Well, sure. Let's go ahead and break these down. All right. So creating a golden AMI. I like this one, but creating a golden AMI, that is going to require a decent amount of work, and we have a couple other issues. One, AMI deployments. Well, what are we doing with that? We're effectively replacing the active instance with a new instance with the updated golden AMI. So a few issues here. One, there's a decent amount of management involved in this. And two, unless we perform a blue-green deployment with the updated AMI, there's downtime here. So that's not really right. Despite the fact that I would rather create a golden AMI. In any case, next up, modify our user data property in our CloudFormation template and update the stack. Well, is that really going to work? So if we perform a stack update, what does changing our user data do, or what is that going to do to our running instance? It's well, not going to have any bearing on it whatsoever. If I remove and then restart this CloudFormation template, then yeah, my user data script will run, but that's going to cause a lot of downtime. Next up, well, let's use CloudFormation to create and deploy a Chef server, bootstrap the EC2 instance with the Chef client software. Well, Chef and CloudFormation together can automate our deployments. Bootstrapping our EC2 instances with the client software, or I'm sorry, Chef client software, the Chef agents on our instances, means Chef will now have the ability to, well, perform our updates. And more importantly, has the ability to do this in an automated fashion by you update your recipes, you update your cookbook and push that update out. So that does match our requirements. And finally, use the update stack API call in CloudFormation to update the stack with a new version of the application. Well, so what happens to applications running on our instances when we update the stack? Well, we're going to replace them. As such, it's going to, well, cause some downtime. Not really an option. We need to minimize our downtime. We could, of course, use CF and Hub to, well, automate these deployments as well. If we are doing that, that could have allowed us to make some configuration updates through the update stack and do so in an automated fashion, while also potentially minimizing, at least compared to this, potential downtime. But it's not listed in the question or in the answer, so we know it's not there. It's not an option, which leaves us with option C. Using CloudFormation to create and deploy a Chef server, bootstrapping the EC2 instances with our Chef client software. All right. So look at King Kong, still happy he won. All right, now at this point, that is leading us to the end of the workshop. So another very, very valuable training tool for practicing and getting or preparing for the certifications is, of course, our instructor-led classes. We are performing instructor-led classes virtually every single week. Now the classes are designed to kind of help guide you in best practices regarding different solutions. You can go to aws.amazon.com/training and look through the different classes. I know we do some free classes, but a lot of them are paid. We have the self-paced labs. We can go to aws.amazon.com/training/self-paced labs, or just go to run.quicklabs.com. And that will give you access to the self-paced labs, which are hands-on labs. Now, for those of you who have taken AWS training classes before, you've probably already used Quick Labs. This is, however, a new, this will be a different Quick Labs environment. Now, the labs do cost money. Generally, it is around 50 cents to a couple of dollars per lab. Some of them are really basic, some of them are free, some of them are really advanced and will take an hour or two. And within the self-paced labs, we also have quests. The quests are generally guided. It's a set of multiple labs that once you complete, generally it takes between 8 to 12 hours to complete all the labs, is really, really good practice. And wouldn't you know it, there is a quest for the Solution Architect Professional exam that I believe consists of 12 labs and will actually give you hands-on experience with a lot of the content that you'll be questioned on. In addition to that, so I do recommend the self-paced labs for everyone if you have time, especially if your company has a bank of hours within the self-paced labs. In addition to that, there's a lot of white papers that I believe have already been posted into chat. Looks like Mark just reposted them for you all. I highly recommend copying down each of these URLs. Now, the white papers are I know they can be kind of dry sometimes, but they're really, really useful. And you can read through all of these white papers in a couple of days. So security best practices, a well-architected framework, architecting for the cloud best practices. If nothing else, these 3 white papers for the SA professional exam, you do really want to read. Now, the rest of them, you still probably want to read because they're really good white papers, and they will also help prepare you for some of our other exams as well. And if you commute for work, I know back before last year, I used to take the metro into work or the DC metro into work, and that took about 45 minutes. So all I did was pull some white papers up on a Kindle and read them on the ride in. It's a great opportunity to get as much information as I could when I was doing nothing else anyway. So I highly, highly advise that. With that being said, that is it for this workshop. Thank you very much. I hope you found this beneficial. I hope my raspy voice this morning wasn't too distracting. And I think we're going to hang out for a little bit. I am going to stop the screen share, but please feel free to hang out and continue asking questions if you want. Aside from that, good luck, everyone. And I hope you all pass your Solution Architect Professional exam.